before we start the class, let us take some warm-up questions, then we'll start the class. Another 15 to 20 quality questions which we'll discuss. First question, please write down question number 1. Question number 1. Question, n equivalent to 41 power, I just got questions in some papers, 41 power 4 plus 31 power 4 minus of 21 power 4 plus 11 power 4. N is always divisible by, n is always divisible by. A very good question. Most of the students will solve by opening the brackets. The idea is to tell you a very different way of solving a question. B65, C30, D20, E65 and 20. N equivalent to 41 power 4 plus 31 power 4 minus of 21 power 4 plus 11 power 4. N is always divisible by. Now listen carefully. Generally what students will do is, they will open this bracket. If you ask me, Anil Nair's way of solving this question, how I will solve this question? How I will solve this question? Listen carefully. What I will do is, I will apply Chinese remainder theorem. I will apply Chinese remainder theorem because all the answer options are composite numbers. Chinese remainder theorem says, if the denominator is a composite number, if the denominator is a composite number, write the number as a product of coprimes. Write the number as a product of coprimes. 42 is nothing but 7 into 6. 65 is nothing but 5 into 13. 20 is nothing but 5 into 4. 30 is nothing but 6 into 5. First what I will do is, I will take an option which is either 65 or 20, because if it is failing with 5, option B, option D and option E, all the 3 will be out. First I will check with 5. If I check with 5, if I divide it, 5 8s are 40, 1, 5 6s are 30, 1, 5 4s are 20, 1, 5 2s are 10, 1, 2 minus 2 is 0. 2 minus 2 is 0. 5 it is giving. 13 3s are, I am using option B. 13 3s are 39, 2 power 4. 13 2s are 26, 5 power 4. 13 2s are 26, minus 5 power 4, which is 5 power 4. 11 divided by 13, 13 1s are 13, minus 2 power 4, which is plus 2 power 4. These also getting cancelled. Right? That means answer is definitely divisible by 65. Either the answer will be this or the answer will be this. In this one, 5 into 13 already done. 20 is 5 into 4. Let me check with 4. 4 10s are 41. 4 8s are 32 minus 1 power 1. 1. 4 5s are 21. 4 3s are 12 minus 1 plus 1. 2 minus 2 is 0. It is also divisible by 65 and 20. It is also divisible by 65 and 20. That means you do not need to open up the bracket and use a power n minus b power n. A power n minus b power n concept. 41 power 4 minus 21 power 4. A power n minus b power n is always divisible by a minus b. You don't need to do it. Whenever the denominator is a composite number, try to use Chinese remainder theorem. It will help you to save your time. It will help you to get the answer in less number of steps. So what I did is, n is divisible by, that means the n is a multiple of the given answer options. Multiple means when you divide it, remainder should be 0. 42 is 7 into 6. 65 is 5 into 13. 30 is 6 into 5. 20 is 5 into 4. 65 and 20. So it's a combination of B and D. First I started with 5. Suppose if the question is not divisible by 5, B, D and E are out. So it is divisible by 5. It is divisible by 13. That means option will be B and E. Then I checked whether it is divisible by 4. 5 into 4 is 20. So 65 and 20. Option E will be the answer. I hope idea is clear. Question number 1. Question number 2. Some very good quality questions based upon the examination pattern. I just got it in one of the papers, so I am just taking down the question. Second question, 1 by 2 factorial, 1 by 2 factorial, plus 2 by 3 factorial, plus 3 by 4 factorial, plus 4 by 5 factorial, and so on. This is and till up to 21 by 22 factorial is nothing but a by b. What is the remainder when b is divided by a? What is the remainder when b is divided by a? Method 1. How students will solve this question is, or how institute will teach is, 1 is nothing but 2 minus 1 by 2 factorial. 3 is nothing but 3 minus 1 by 3 factorial. 4 is nothing but 4 minus 1 by 4 factorial, and so on. 21 is nothing but 22 minus 1 by 22 factorial. This is nothing but 1 minus 1 by 2 factorial plus 3 by 3 factorial is 3 factorial is 3 into 2 factorial. 1 by 2 factorial minus 1 by 3 factorial. 4 by 4 factorial is nothing but 1 by 3 factorial minus 1 by 4 factorial, and so on up to 1 by 21 factorial minus 1 by 22 factorial. Every plus is preceded by the minus sign. Every plus is preceded by the minus sign. So, every plus before minus sign is there. Every plus before minus sign is there. So, this is nothing but 22 factorial minus 1 divided by 22 factorial. That means if I call it as a minus 1 by a minus 1 and a are consecutive natural numbers. Consecutive natural numbers. 4 divided by 3, remainder 1. 5 divided by 4, remainder 1. Remainder when 22 factorial is 22 factorial is divided by, not a is divided by b. I think this is a by b. Remainder when b is divided by a, it is nothing but 1. This is the traditional method of solving the question. This is a traditional method of solving the question. Traditional way of solving the question, writing the numerator as 2 minus 1, 3 minus 1, 4 minus 1 and everything. I hope it is clear. Still there is, you can further simplify the problem. If you are able to solve this question in 1 minute, I will tell you a 5 seconds approach. This is method 1, method 2, method 2. Method 1, I hope it is clear, right? These both are consecutive natural numbers. Consecutive natural numbers remainder is 1. Method 2. Method 2. Method 2. These are nothing but 1 by 2 factorial plus 2 by 3 factorial plus 3 by 4 factorial and so on up to 21 by 22 factorial. It is a by b. First take 1 by 2 factorial, 1 by 2. Take two terms, 1 by 2 plus 2 by 6, which is nothing but 1 by 2 plus 1 by 3, which is nothing but 5 by 6. If 6 is divided by 5, what is the remainder? 1. So, from second term onwards, if you take first, second and third, again you will get denominator is just 1 unit greater than the numerator. So, answer is always 1. Condense it to small steps. Condense it into smaller steps. Condense it into smaller values. Condense it into smaller values. Condense it into smaller values. First value 2, 1 anyway will divide any natural number. So the first one might not give you the answer directly. Go from the second one onwards. 1 by 2 plus 1 by 3, which is 5 by 6. 6 when divided by 5, which is nothing but 1. Even if you take third also, you will get the answer. 1 by 2 plus 2 by 6 is 1 by 3. 3 by 4 factorial, which is 1 by 8. So if you try to solve 24, these are nothing but 12, these are nothing but 8, these are nothing but 3. 23 divided by 24. 24 when divided by 23, remainder is always 1. So in these simplification related problems, you can go by taking the first two values, check by the answer. For just an additional confidence, go for the first three values. Question number 1 and 2. I hope it is clear. Question number 3. Question number 3. Another beautiful question. 29A031 into 342 equivalent to 100,900B02. Find the value of A and B. Find the value of A and B. A classic question based on the divisibility rule. Classic question based on the divisibility rule. 29A031 into 342, it is nothing but 100,900B02. Now if you see here, solution, key points, first key point, 342 sum of the digits is 9. 9 into any number, 9 into any number, the digital sum in the answer is always 9. 9 into any number, digital sum in the answer is always 9. Based on this one, 1 plus 2, 6, 9 is anyway eliminated. 6 plus B should be divisible by 9. 6 plus B should be divisible by 9. 1 plus 2, 3, 3. 3 plus 9, 12. What is the next multiple of 9? 18. 6 plus B should be divisible by 9. So B value is 3. So we got B value 3. Once we got B value 3, it is nothing but 29A031 into 342 equivalent to 100,900,302. One way is divide and do it. That is a very complicated method. Now see here. This is 342 is divisible by 9. 100,900. Now if you see, this is divisible by 9. If I check the divisibility rule of 11, if I check the divisibility rule of 11, if I check the divisibility rule of 11, what is divisibility rule of 11? Sum of odd places, sum of odd places minus sum of even places, minus sum of even places should be divisible by 11. Sum of odd places minus sum of even places should be divisible by 11. 3 plus 2, 5. 5 plus 0, 5. 5 plus 0, 5. 5 plus 1, 6. I hope it is clear. 2 plus 3, 5. 5 plus 1, 6. If I take an even number, so these 0 plus 0, 0. 0 plus 9, 9. 9 plus 0, 9. Now if you see here, I think we made a mistake. 9 plus 1 plus 2. 12 plus B should be divisible by 9. 12 plus B. I think why I took 3 plus B? Here it is. 3 plus B should be divisible by 9. B value is 6. B value is 6. I think I made a calculation mistake. Please make a note of it. Here it is. Here it is. I think in hurry I wrote 9 cancel, 3 plus B should be divisible by 9. So B value is 6. If B value is 6, if B value is 6, if B is 6, so this will be 2 plus 6, 9 minus 9, it should be divisible by 11. That means this number is divisible by 11. This is not divisible by 11. This number should be divisible by 11. If I take the sum of the odd places, 1 plus 0, 1, 1 plus 9, 10, 10 minus of 3 plus A plus 2 plus A, 10 minus of 5 plus A should be divisible by 11. That means sum of odd places minus sum of even places should be 0 or divisible by 11. So A value is 5. A value is 5 and B value is 6. I made a small mistake at the beginning in calculating the B. Please make a note of it. The very beautiful question. This question uses the divisibility rule of 9 and 11. This question uses the divisibility rule for 9 and 11. Question number 3. Divisibility rule for 9 and 11. 342 sum of the digits is 9. If you multiply any number by 9, answer should be divisible by 9. I used that first concept and I got the value as b value 6. I got the answer for the right hand side as 100900602. That number seems to be divisible by 11 just by looking at the face value of the question, right? Once it is divisible by 11, 342 is not divisible by 11. 29A031 is divisible by 11. Divisibility rule of 11 is sum of the odd places minus sum of the even places should be divisible by 11. I hope it is clear. Question number. Another very good question which we will take it. Question number 4. Find the sum of the perimeters. Find the sum of the perimeter of all rectangles with integral sides. Find the sum of perimeter of all rectangles with integral sides. Sides should be an integer value with integral sides and area 120 unit square. And area 120 unit square. And area 120 unit square. Very good question. Area is given as 120. He is asking the sum of perimeters of all rectangles. Sum of perimeters of all rectangle, and the sides should be an integer. Suppose if area is 8. Remember, in rectangle, length is always greater than breadth. Reverse case is not allowed. So this question is based on unordered pair. Reverse we cannot take. So area is length into breadth is 8. Length is greater than breadth. So 8 into 1. Next is 4 into 2. 1 into 8 and 2 into 4. This case is not possible. I hope it is clear, right? What is the perimeter? Perimeter is given by 2 into L plus B. Perimeter of a rectangle is given by 2 into L plus B. So it is 2 into 1 plus 8. It is 2 into 2 plus 4. He is asking sum. Sum is nothing but 2 into 1 plus 2 plus 4 plus 8. Am I right? Now simply if you observe, if area is 8, 8 is 2 cube. What are all the factors of 2 cube? 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 0, 2 power 1, 2 power 2, 2 power 3. What is that we got? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So these L plus B is nothing but the sum of the factors for this number. Because perimeter is 2 into L plus B, answer for this kind of question is nothing but 2 into sum of the factors. Why sum of the factors came into picture? Length plus breadth. 1 plus 8 I got. Next 2 plus 4 I got. 1 plus 2 plus 4 plus 8. 1 plus 2 plus 4 plus 8. That is nothing but the sum of the factors for 8. 1 plus 2 plus 4 plus 8 is nothing but sum of the factors. Whenever the area is given, he is asking you to find the sum of perimeters of all rectangles with integral sides. Answer is nothing but 2 into sum of factors. With this simple example of area 8, now let us solve the question. Now see here. What is the question? Area is 120. Area is 120 unit square. 120 is nothing but 2 cube into 3 into 5. 2 cube into 3 into 5. So answer is nothing but 2 into sum of the factors for 120. 2 into sum of the factors for 120. 2 into sum of the factors for 120. 2 into, what are the sum of the factors for 2 power 3? Write all the powers of 2 starting from 0 to 3. 2 power 0, 2 power 1, 2 power 2, 2 power 3. Write all the powers of 3 starting from 0. 3 power 0 plus 3 power 1. Write all the powers of 5 starting from 0 to 1. This is how you calculate the sum of the factors for 120. 2 into 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. 15 into 1 plus 3, 4. 1 plus 5 is nothing but 6. So this is nothing but 30 into 24, which is nothing but 720 units. 720 units. Perimeter of a rectangle with, perimeter of a rectangle with area 120 square, area 120 unit square, and integral sides is given by 2 into sum of the factors for 120. Perimeter, why 2 into came? Perimeter of a rectangle is 2 into L plus B. L plus B means you are adding all the factors of that number. Remember, in area of a rectangle, length is always greater than breadth. Length is always greater than breadth. I hope question number 4 is clear. Question number 5. Question number 5. There is a number. This number has got 4 factors. This number has got 4 factors. Sum of all the factors excluding the number, sum of all the factors excluding the number, it is 31. It is 31. Find the sum of all such numbers. Find the sum of all such numbers. Find the sum of all such numbers. There is a number, it seems, and the number has got 4 factors. 4 factors. Sum of all the factors excluding the number. Now, a number has got 4 factors. 4 factors, it is nothing but, it could be 1 into 4. Morning we discussed this model. It could be 2 into 2. 4 means, first it will be P1 power 3. P1 power 3. What are the factors of P1 power 3? P1 power 0, P1 power 1, P1 power 2. Now excluding the number. Number should not be taken. P1 power 3 should not be taken. So this is nothing but 1 plus P1 plus P1 square equivalent to 30. So P1 into 1 plus P1, it is 30. P1 is nothing but 5. First value we got it as the number which has got 4 factors and the sum of the factors excluding the number which is nothing but 5. First thing we got it as 5 cube. 5 cube. Next 2 into 2, which is nothing but P1 power 1 into P2 power 1. What are the factors for this number? P1 power 0 plus P1 power 1. P2 power 0 plus P2 power 1. Excluding the number P1, P2, this should not be taken. It is equivalent to 31. I hope it is clear. So this is nothing but P1 plus P2 equivalent to P1 power 0 is 1, P2 power 0 is 1. So 1 plus 1, 2. 31 minus 2 is 21. What are P1 and P2? P1 and P2 are nothing but the prime numbers. P1 and P2 are nothing but the prime numbers. So which all cases are possible? 2 plus 27 not possible. 3 plus 26 not possible. 5 plus 24 not possible. 7 plus 22 not possible. 11 plus 18 not possible. 13 plus I think P1 plus P2 is 29. 29 means which all cases? 2 plus 27 not possible. 3 plus 26 not possible. 5 plus 24 not possible. 7 plus 22 not possible. Not possible. Next one, 9 plus 20. 9 plus 20 not possible. 11 plus 18 not possible. 13 plus 16 not possible. 17 plus 12 no. 23. Which all cases are possible? Just look into it and tell me which all cases are possible. I hope it is clear, right? 5 power 3 we got it. Right? I think 2, 3, 5, 7, 11, 13. 17 plus 12 not possible. 23 plus 6 not possible. None of this case is not possible. So only case possible is 5 cube. In that 5 cube, what is the sum of all such numbers? Only one number I got, and that number is 125. And the number is 125. I hope the idea is clear. There are 4 factors. 4 factor means 1 into 4, 2 into 2. 4 means P1 power 3. Sum of all the factors, P1 power 0, P1 power 1, P1 power 2, P1 power 3. This case not possible. P1 plus P square. P1 into 1 plus P1 is 30. P1 is 5. If P1 is 5, next case, P1 power 1, P2 power 1, P1 power 0, P1 power 1, P2 power 0, P2 power 1, plus P1, P2, the number should not be taken. No case I am getting. No case I am getting. Why no case we will get? I think you don't need to do all these cases. See, sometimes my brain does not work super fast. All these things you don't need to take. P1 power plus P2 is 29. If this is an odd number, if this is an odd prime number, odd plus odd has to be an even number. That means 2 odd prime numbers, it is not possible. If this is an even number, this has to be an odd number. So just check it out. If this is 2, P2 is 27. This case not possible. No such case will be possible. Just you use the nature of a prime numbers, you will get this answer. I hope this question is clear. Next, question number 6. Question number 6. Very good quality questions which we'll solve in our class. Question number 6. Reminder 1. 41 factorial whole square divided by 83. Reminder 1. 41 factorial whole square divided by 83. Now see here. Solution. Now before we discuss some important key points, reminder 1. P minus 1 factorial divided by P. It is nothing but P minus 1. Reminder 1. P minus 2 factorial divided by P. It is always 1. Reminder 1. P minus 3 factorial divided by P. It is nothing but P minus 1 by 2. What is P here? P is a prime number. P is a prime number. Wilson's theorem conclusions. P minus 1 factorial divided by P is P minus 1. P minus 2 factorial when divided by P is 1. P minus 3 factorial when divided by P is P minus 1 by 2. You can take any of this, you will get the answer. Solution. Suppose if you see, reminder, I am taking the second one. 83 is a prime number. 83 minus 2 is 81 factorial. 81 factorial divided by 83 is 1. This is nothing but 1 into 2 into 3 till 41. 42 till 81 divided by 83. It is 1. 1 into 2 till 41, which is nothing but 41 factorial. 42 divided by 43 minus 1. 43 divided by 83 minus 40. 81 divided by 83 minus 2 divided by 83. It is 1. 2 to 41. Total 40 negatives are there. 40 negatives, if I multiply, I will get positive. So answer for this question is nothing but 41 factorial whole square divided by 83 is always 1. is always 1. I will do another question. I wanted to tell you answer for this kind of questions is not always 1. There is a slight twist in this question. Right? 41 whole square divided by 83. If I take this conclusion, 41 factorial minus 41 minus 40 minus 2. 2 to 41 is 40. 40 negatives, if I multiply it is positive. 41 whole square divided by 83 is always 1. Take one more question. Take one more question. Then you will understand. Some teachers out of their innocence and ignorance, they will tell you 83 minus 1 by 2 which is 41 factorial, answer is 1. Question number 7. Reminder 1. 35 factorial whole square when divided by 71. 35 factorial whole square when divided by 71. Let us solve this question also. So already we discussed. Reminder 1. P minus 2 factorial. P minus 2 factorial when divided by P, it is always 1. So this will become reminder 71 minus 2. 69 factorial when divided by 71 is 1. 69 factorial is nothing but 1 into 2 into 3 till 35 into 36, 37 and so on up to 69 when divided by 71 is 1. 1 into 2 till 35 is 35 factorial. 36 divided by 71 is minus 35, minus 34 and so on up to minus 2 divided by 71 is always 1. 2 to 35. 34 numbers are there. 34. I hope it is clear, right? 2 to 35. 34 negatives are there. 34 negatives turned positive. Here also you are getting 1. 35 factorial whole square divided by 71. These resulting in 1. I hope it is clear. 2 to 35 is 34 negative. We'll take one more. We'll take one more. Right? Why? Because 71 is 6 into 12 minus 1. 12 is a composite number. Previous question 83 is 6 into 14 minus 1. 14 is a composite number. Let me take a prime number multiple of 6. Let me see if the answer is changing. It will change. Next one. Question number 8. Question number 8. 8 factorial whole square divided by 17. 8 factorial whole square divided by 17. Now this will be 17. Solution. Reminder 1. 15 factorial divided by 17 is 1. 15 factorial divided by 17 is 1. 15 factorial is 1 into 2 into 3 and so on up to 8 into 9 into 10 into 11 and so on up to 15. When divided by 17, it is nothing but 1. Reminder 1. 1 into 2 into 3 till 8, which is nothing but 8 factorial. 9 by 17 is minus 8, minus 7 and so on up to minus 2 divided by 17, which is nothing but 1. 2 to 8, there are 7 negatives. 7 negatives, if I multiply, I will get a negative. So these are nothing but 8 factorial into minus 8 factorial. I hope you understood the point. Divided by 17, it is nothing but 1. Reminder 1. 8 factorial whole square divided by 17 is minus 1. Positive minus 1 means positive answer 16. Minus 1 means positive answer 16. I hope the idea is clear. I hope the idea is clear. It is not always 1. Sometimes it gives a minus 1. When it gives minus 1, when the denominator is a prime multiple of 6 into 3 minus 1. Remaining all are composite multiples. Remaining all are composite multiples. I hope question number 8 you got an idea. Question number 9. Please write down, sir. Question number 9. Question number 9. 2 power 28 minus 1 is exactly divisible by two number, or we'll write down here. Question number 9. 2 power 28 minus 1 is exactly divisible by two numbers between 120 and 130. Between 120 and 130. Find the sum of the two numbers. Find the sum of the two numbers. Options are 255, 256, 257, 259, 259. This is a very, very good question in terms of the conceptual clarity. You don't need to do anything. 2 power 28 minus 1 is divisible by two numbers A and B. Right? It is divisible by two numbers. 2 is an even number. Minus 1 is an odd number. Even minus odd is odd. This number is divisible by two numbers A and B. Odd. The product of two numbers will be odd. When it will be odd, this is odd and this is also odd. Are you all with me? Right? That means odd is nothing but odd into odd. I require the sum of these two numbers. Odd plus odd is an even number. Answer is nothing but 256. Answer is nothing but 256. This is one way to solve. 2 power 28 minus 1. Odd minus even minus odd is odd. Odd number is divisible by two numbers. Odd number is divisible by two numbers means that two numbers has to be odd into odd only. How can it be odd into even? Odd into even is even. How can it be even into odd? It is even. How can it be even into even? It is even. The only case possible is A has to be odd, B has to be odd. If I add these odd plus odd is an even number. Answer is 256. Now, in case if you want the numbers, you don't want to do it like this, you want to find out the numbers. Then what you can do is, you can use A power n minus B power n logic. 2 power 28 minus 1. These are nothing but 2 power 7 power 4 minus 1 power 4. A power n minus B power n is always divisible by A minus B and A plus B. It is divisible by A minus B and A plus B. So if I use that concept, it is divisible by 2 power 7 minus 1 and 2 power 7 plus 1. 128 minus 1 is 127. 128 plus 1 is 129. Sum of these two numbers, which is 256. Sum of these two numbers is 256. I hope the idea is clear. Exactly that is what I said. This is an odd number. Odd plus odd has to be an even number. I hope the idea is clear. Question number 9. Question number 10. Question number 9. Question number 10. Very, very good questions. I am selecting from some of my previous year classroom notes. Question number 10. All are picked out from my number system book which I wrote it. Now, question number 10. Now see, the question is reminder 1, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4 and so on up to 36 digits. 36 digits. 36 digits. 36 digits. 36 digits when divided by 36 leaves a remainder of how much? 1, 1, 2, 1, 2, 3, 1, 2, 3, 4 and so on up to 36 digits. When divided by 36 is how much? Solution. This question is like this. Now if you see, just a little bit of, I will write it vertically, 1, 1, 2, 1, 2, 3. Now see here, if it is ending with 2, it is nothing but summation 2. Summation 2 is n into n plus 1 by 2. 3 digits I wrote, 1, 2, 3. If it is ending with 3, totally summation 3, which is n into n plus 1 by 2, which is 6 digits I wrote. That means if it is ending with 2, there is a summation 2 digits. If it is ending with 3, it is a summation 3 digits. If it is ending with n, total 36 digits are there. So total summation n is 36. N is nothing but n into n plus 1 by 2 is 36. So n value is 8. That means the last number that is formed is nothing but 1, 2, 3, 4, 5, 6, 7, 8. If it is ending with 2, summation 2. If it is ending with 3, total digits are summation 3. If it is ending with n, total digits are summation n. Summation n is 36. N into n plus 1 by 2 is 36. N value is 8. That means this entire question is nothing but a reminder. We will write the question like this. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. This entire thing is divided by which number it is asked? It is divided by 36. 36 is 4 into 9. 4 means the last 2 digits should be divisible by 9. 4 19s are 76. Remainder 2. So the first case is 4a plus 2. Second case it is divided by 9. 9 means, see here, this is a very good example. 3, 4, 5, 2. 3 plus 4, 7, 7 plus 5, 12, 12 plus 2, 14, which is 5. Which is 3 plus 4 plus 5 plus 2. Even if you take 34 plus 52, even if you take 345 plus 2, digital sum will not change. Check here, 34 plus 52 is 86, which is 5. 345 plus 2 is 347, again digital sum 5. So what I will do is, here I will do it in this order. So here it is 1. Here it is 1 plus 2, 3. Again addition of 2, addition of 3, addition of 4. I hope the series is clear. Addition of 5, addition of 6. These plus 2, here plus 3, here plus 4, here plus 5, here plus 6. Addition of 7, addition of 8. 36 is over, these over, these over, these over. 1 plus 1 plus 1, 9b plus 3. 4a plus 2 equivalent to 9b plus 3. Now once what you do is, 4a is equivalent to 9b plus 1. 4a is equivalent to 8b plus b plus 1. So these is divisible by 4, divisible by 4. B value is 3. 27 plus 3. Answer for this question is 30. 4a plus 2 equivalent to 9b plus 3. 4a is 9b plus 1. 4a is 8b plus b plus 1. 4a it is divisible by 4. 8b it is divisible by 4. b plus 1 should be divisible by 4. So b value is 3. 9 3s are 27 plus 3, which is 30. I hope it is clear. I hope it is clear. Right? Idea clear, right? Next question. Question number, you can take one more question. Good question we will solve. Question number 9, I believe. Question number 9. Question number 9. Then we will solve some questions present in the PPT. Question number 9. Question number 9 is nothing but a very, very good question. M is nothing but product of all even numbers. M is nothing but product of all even numbers from 1 to 25. Product of all even numbers from 1 to 25, which is 2, 4, 6, 8, 10, 12, 14 and so on up to 24. 2 ones are, 2 twos are, 2 12s are. 2 power 12 into 12 factorial. This is the representation. N is the product of all odd numbers. N is the product of all odd numbers. Product of all odd numbers from 26 to 200. Because I require M into N has dash zeros at the end. M into N has dash zeros at the end. Number of zeros is nothing but the power of 2 and 5. 2 anyway will not come in this odd number. Only I will take the multiples of 5. It's a very, very good question. Lot of students tend to think that number of zeros is always power of 5, which is not right. N is the product of all odd numbers. I will not take any power of 2. 35, 45, 55, 65, 75, 85, 95, 105, 115, 125, 135, 145, 155, 165, 175, 185, 195, 175, 185, 195. Now see here. Listen carefully. Now a beautiful problem, sir, it is. So this is nothing but 2 power 12 into 12 contains how many powers of 2? 2 6 are, 2 3s are, 2 1s are. 2 power 10 into k. It is 2 power 22 into remaining 5 bases. 5 7s are 1 power of 5. 5 9s are, 5 11s are, 5 13s are, 25 3s are 2 power. 5 17s are, 5 19s are, 5 21s are, 5 23s are, 5 cube, 5 27s are, 5 29s are, 5 31s are, 5 33s are, 25 7s are, 5 37s are, 5 39s are. Totally how many I got? 1, 2, 3, 4, 6, 7, 8, 9. 10, 13, 14, 15, 16, 17, 19, 20, 21. So N is nothing but 5 power 21 into K2. So M into N is nothing but 5 also. How much we got? 5 power 2 is there. 5 power 2 into K. So it is nothing but 2 power 22 into 5 power 2 into 5 power 21 into K1 into K2. Now what did you observe? 21 plus 2 is 23. 2 power 22 is less than 5 power 23. So I got the answer as 22. 22 has resulted because of power of 2, not because of power of 5. Number of zeros at the end. Only for factorial problems it is nothing but power of 5. But for another problems it may not be equivalent to power of 5. It may or may not be. Just look at this question, sir. Just look at this question. M into N. M is the product of all even numbers. Even numbers are from 2 to 24. 2 1s are, 2 2s are, 2 3s are, and so on up to 24. 2 power 12 into 12 factorial. 12 is nothing but 5 square. Right? It is nothing but power 10. So it is nothing but 2 power 22 into 5 square into k. Odd numbers. Odd number will not have any power of 2. So only 35, 45 like that I took it. So I counted how many powers of 5 are there. I got total 5 power 21. M into n is this one into k1, n is this one into k2. 21 plus 2 is 23. 2 power 23 in 22 into 5 power 23. Lowest is nothing but 22. Question number 9. I hope it is clear. Next one. Question number 10. Very, very good question. Question number 10. Write down this question. You are selecting 10 numbers. You are selecting 10 numbers. 10 numbers out of first 100 odd numbers. Out of first 100 odd numbers. Out of first 100 odd numbers. Sum of these 10 odd numbers is A. Sum of these 10 odd numbers is A. How many different values A takes? How many different values A takes? How many different values A takes? Solution. Very, very good question, sir, it is. You are selecting 10 numbers out of first 100 odd numbers. Immediately, students who have not read the question will tick mark 100 C 10 as the answer. But that is only the first statement of a question. Sum of these first 10 odd numbers is A. How many different values A takes? 100 odd numbers. 1, 3, 5, 7, 9 and so on. 100th odd number is 199, 181, 183, 185, 187, 189, 191, 193, 195, 197, 199. These are all 100 odd numbers. If I take the sum of the lowest 10 odd numbers, 1 plus 3 plus 5 plus 7, 9 plus 11 plus 13 plus 15 plus 17 plus 19. First 2 odd numbers it is 4 which is 2 square. First 3 odd numbers it is 9 which is 3 square. First 4 odd numbers it is 4 square. First 10 odd numbers 10 square it is 100. 100. Listen carefully, sir. Listen carefully here. From here to here the sum is 100. Suppose I remove these 19. I have to select 10 odd numbers. I will replace it with 21. Till here the sum is 81. 81 plus 19 is 100. 81 plus 21 is 102. Yes or no? Right? If I replace 19 with 23. Till 17 it is 81. 81 plus 23 is 104. Am I right? If I am replacing 19 with 21, I am getting 102. If I am replacing 19 with 23, I am getting 104. Like that, the sum 102 can also come from another possibility of replacing 17 with some other number. Yes or no? Yes or no? For example, instead of if I replace 19 with 23, I got the sum 104. Suppose if I replace 17 with 23, if 17 is not there, till here the sum will be 83 because 83 plus 17 only is 100. I replaced 17 with 21. What is 83 plus 21? 104. 104 sum can also come if I replace 19 with 23. Can also come if I replace 17 with 21. That means every NCR will not give you a unique value. There could be a repetition. Are you all with me? Are you all with me? Why 100 C10 is incorrect? I hope you got it. 100 C10, every value will not give me a unique. If I replace 19 with 23, I got a unique value 104. If I replace 17 with 21 also, I got 104. So the first thing which is there is I am getting all even numbers. The second thing is answer is not 100 C10. Now what I will do is, now I will solve it logically. Now what I will do is I will solve it. Now see here. Till here I hope it is clear. Now 1 minute. Now till here I hope it is clear. Now I will do what is the lowest 10 odd numbers, 1, 3, 5, 7, 9 and so on up to 19. What is the sum I got? 100. Let me take the highest, 181, 183, 185, 187, 189. 191, 193, 195, 197, 199. 185s are 900, 900 plus 16, 21, 25. Similarly, 195s are 950 plus 25. So which is nothing but 1900. That means all even numbers only I am getting. I have to take all even numbers from 100 to 1900. Why all even numbers I have to take? If I add 10 odd numbers, if I add even number of odd numbers, I will always get answer even. I will never get odd number. Even numbers from 100 to 1900. So 1900 to 100, total 1801 numbers are there. 901 will be even because first and last is also even. Answer for this question is not 100 C10 but answer is 901. I hope the idea is clear. Please understand this question. Do not tick mark 100 C10 just by reading the first question. There are 100 odd numbers. I wrote the odd numbers from 1357 to 199. I took the lowest 10 odd numbers, 100. I took the highest 10 odd numbers, which is 1900. If I change one odd number to another odd number, the shift is by 2 units, it is growing. Obviously 19, if I remove, add 21, the shift will be plus 2. That means 100, 102, 104, 106, 108 and so on up to 1900. 100 to 1900, it is 1801 numbers, out of which 901 will be even, 901 will be odd. Answer for this question is 901. I hope question number 10 it is clear. I hope it is clear, right? Question number 11. Analyze each and every question. This video will be kept in our enrolled students portal in probably by tomorrow night and or Tuesday morning. Ensure that you revise every problem. Question number 11. Question number 11. A into B equivalent to 510, 510. A and B HCF it is 1. HCF of A comma B equivalent to 1. How many values A comma B will take? How many values A comma B will take? Now see here, the entire this question tells you how you can factorize it. A into B is, it is ending with 0, so 2. 5 plus 1, 6, 5 plus 1, 6. It is ending, it is 3. It is ending with 0, so 5 will come. Take any 3-digit number, written even number of times. Any 3-digit number, written even number of times. Any 3-digit number, written even number of times. If I take a 3-digit number, if I write even number of times, is always divisible by 7, 11, 13. Any 3-digit number written even number of times is always divisible by 7, 11, 13. So 7, 11, 13. 17 30s are 5, 10. So into 17. It could be some K1, some K2, some K3, some K4, some K5, some number K7. I hope it is clear. Ending with 0, it has to be an 2. Ending with 0, it has to be 5. 0 means it is an even number or divisible by 5. Divisibility rule of 3. Sum of the digits should be divisible by 3. Any 3-digit number written even number of times is always divisible by 7, 11, 13. Morning what we discussed, if variables are present in the question, it is nothing but an ordered pair. In an ordered pair, answer is nothing but 2 power p. What is p? P is nothing but the count of prime bases. P is nothing but the count of prime bases. 2 power 1, 2, 3, 4, 5, 6, 7. 2 power 7. Answer is, in how many ways can you write this number as a product of 2 co-primes? If variables are present, 128. If variables are not present, it is 64. I hope question number 11, it is clear to you. Question number 12. Now, before we solve this question, I think this question you can solve it if you have understood the approach. This is missing in our PPT. There are 2 or 3 questions which are missing. Let us see that questions. All these questions morning with the concept we discussed. Now, I think this every third natural number starting from 1 up to 1000 is multiplied. Find the number of 0. I will just give you the concept. What are the numbers? 1, 4, 7, 10, 13, 16, 19, 22, 25 and so on. Am I right? And so on up to 1 plus 3k. So it is up to 1000. Step number 1. Find out number of zeros means find out the multiples of 5. Where all the multiples of 5 are there? First is 10. Next is 25. Again increase 15, 40. Again 55. Again 70. Again 85 and so on. Are you all with me? 10, 25, 40 and everything. That means 10, 25, all these numbers are multiplied. So how many numbers are there? Let us see. This is nothing but 10 plus 15k format. Should be less than 1000. That means 15k is less than 990. K is less than 15 6 are 90, 15, right? So that means k will be from 0 to 65. 66 numbers are there which are multiples of 5. 66 numbers are there which are multiples of 5. I hope the idea is clear. 66 multiples are there which are multiples of 5. Answer has to be greater than 66. Step 2. Multiples of 25. Extra will come. Multiples of 25. Let us check whether what are all the multiples of 25 are there. So series is like this. 1, 4, 7, 10, 13, 16, 19, 22, 25. Now 28, 31, 34, 37, 40, 43, 46, 49, 52, 55, 58, 61, 64, 67, 70, 73. I think which all multiples are there? That is what multiples of 5 we have taken. Multiples of 5 we have taken. Where all it is? 10, 25, 15, 40, yes, 55, 70. So here we got one answer, 10, 25, 40, 55, here we got. Now multiples of 25 we have to take, because 25 contains extra 5. Then we have to take multiples of 125. Let me search for, first it is 25. If I get the second number, I will get the answer. I hope. For this we got 66. So 25 square 25, extra 1 will come. 55, 73, 76, 79, 82, 82, 85, 88, 91, 90. Okay, I think 82, 85, 88, 91, 94, 97, 100. That means 25, 100. What is the difference? 75. Next it will be 175. Next it will be 175. I hope it is clear, right? Right? 175 and everything. 25 plus 75k. In this one, how many numbers are there? Less than 1000, count it. Similarly, for multiples of 125, count it, add all of this. I hope you got the idea. 25 is 5 square, 125 is 5 cube. So extra whatever powers are there, that try to find out from this, because 25 is already here, one only is counted. 5 square, 5 square, 5 cube, like that extra 5s will come. Multiples of 5 do, multiples of 25 do, multiples of 125 also do it. Question number 18, write calculation intensive problem. If this is given in the exam, this will be in round 3. Round 3 are the questions which you know how to solve, but it is very time consuming. You will first select the questions which you can solve it without using pen. Second, you will select the questions which you think you can solve and also solve it in less time. Question number 18. I hope the idea is clear. I hope the idea is clear. Which question we have not solved in this one? I think 23, 24, these also we solved it. We solved it. Successive also we solved, cube also we solved, 13 we solved, these also we solved. These LCM into HCF is N1 into N2. These also we solved, these also we solved. That means go back. What are the questions that are pending? We will solve that one. Right. Question number 24. 24 is, how many numbers from 1 to 100 are divisible only by 2? The best way to solve this question is by using Venn diagrams, because there are 3 sets. Easily you will understand how you can do it. Now these are the numbers which are divisible by 2. These are the numbers which are divisible by 3. These are the numbers which are divisible by 7. How many numbers are divisible only by 2? Only by 2. Only by 2. But neither by 3 or nor by 7. That means what we have to do is, one way to solve this question is, find out these total. In these total, subtract this case. Right? Or what you can do is, you do this, n of 3, you do this, n of 7. So n of 2 minus of, do n of 3 plus n of 7 minus of n of 3, that is added first, minus of n of 3 intersection 7. I hope it is clear. I hope it is clear. So these is nothing but, this entire 3 is nothing but one mistake which I did. It is nothing but n of 6. These nothing but, This entire portion is nothing but n of 14. N of 14. I hope it is clear. Next, this entire portion is nothing but n of 2 intersection. I think I will write it again here. Just another calculation intensive question. N of 2, we did it. Now, first thing what am I doing is, I am eliminating this common region. What is common region? Common region is n of 2 intersection 3. This I am eliminating it. Next I am eliminating this region. N of 2 intersection 7. In that one, there is a region which is common. I think why to write this as a thing, we will try to solve it. These only, instead of doing this, it is best to find the values. These n of 2, these n of 3, these n of 7. 7, 3, 2. 7 2s are 14, 14 3s are 42. 42, how many numbers will divide up to 100? 42 2s are 84. 2. These nothing but n of 6. N of 6 is nothing but how many multiples of 6 are there till 100? 6 16s are 96, 6 17s are 102. 16 numbers are there. So these 14. How many multiples of 2 and 7 are there? 14 till 100, 14 7s are 98. 7 are there, already 2 is there, so it is 5. How many total multiples of 2 are there till 100? 50. So this region is 50, 14 plus 2 16, 16 plus 5 21. It is 29. You don't need to write all this. 29. I hope it is clear. 2 is nothing but n of 2, 3, 7. 6 7s are 42. Number of numbers which are multiples of 42 is 2. N of 2 comma 3, which is n of 6. How many multiples of 6 are there till 100? 16. 2 is written, so remaining 14. This is nothing but n of 2 comma 7, n of 14. How many multiples of 14 are there till 100? 14 6 are 84, 14 7s are 98. 7, 2 is there, so remaining it is 5. So these 5, these 14. 14 plus 5 19, 19 plus 2 21, total it is 50, remaining is 29. I hope it is clear, idea is clear. Just 1 minute. Right, sir. Next question number 24 over, 23, 21, all these are over. Now we will do the first question which I did not solve, but for that one I need to give an introduction to you. Introduction. Now see, take a number, there is a number 2n. 2n has 20 factors. The same number when multiplied by 3, 3n has 30 factors. If I multiply by 6, 6n has how many factors? 6n has how many factors? You can solve this problem in multiple ways. So method 1 we will do. Method 1. We will take the number as a power of prime bases. 2 power a into 3 power b into 5 power c and so on. Factors for n will be a plus 1 into b plus 1, remaining I will call it as x. X is c plus 1, d plus 1 and something, which I am more focused about 2 and 3 because the coefficients of n are 2 and 3. 2n is nothing but 2 power a plus 1 into 3 power b into 5 power c. Factors for 2n. Factors for 2n will be a plus 2 into b plus 1 into x, which is 20. Factors for 3n. Factors for 3n will be 3 into n, 2 power a into 3 power b plus 1 into 5 power c and so on. A plus 1 into b plus 2 into x equivalent to 30. I hope till here it is clear. Till here it is clear. So 2 minus 1. Let me call this equation 1, this equation 2. 2 minus 1. So 30 minus 20 is 10. X into AB cancel. AB plus a minus 2a. So minus a I will get 2b minus b. X into b minus a equivalent to 10. Till here it is clear. X into b minus a equivalent to 10. If x into b minus a is equivalent to 10, now I will write it in the first slide. Till here it is clear, right? And any natural number can be written as a power of prime basis. Factor for n multiplied by 2n multiplied by 3, 1 minus 2. Now what we'll do is x into b minus a equivalent to 10. This could be 1 into 10, this could be 2 into 5, or this could be 5 into 2, this could be 10 into 1. There are 4 choices that will come. So n is nothing but 2 power a into 3 power b into 5 power c and so on. So 2n, how much we got? A plus 2 into b plus 1 into x equivalent to 20 we got. 3n, how much we got? A plus 1 into b plus 2 into x, we got it as 30. So if I take this case, x is 1, b minus a is 10. If x is 1, a plus 2 into b plus 1 is 20. B minus a is 10. That means, what is b value? A plus 10. A plus 2 into a plus 1, a plus 11 equivalent to 20. Equation is nothing but a square plus 13a equivalent to minus 2. It is not possible. If I take this case, x is 2. So a plus 2 into b plus 1 into 2 equivalent to 10. B minus a is 5. B will be 5 plus a. B will be 5 plus a. So a plus 2 into 5 plus 6 plus a equivalent to 10. A square plus 6a to 8a. These a plus 6. Again I am getting negative. A square plus, I hope you got an idea, equivalent to minus 2. These are not possible. Next 5 into 2. If I take 5 into 2. If I take 5 into 2, like that this question becomes a little cumbersome in terms of cases. You have to get that case right, then you will get the answer. If x is 5, b minus a is 2, x is 5, a plus 2 into b plus 1, it is nothing but 4. B is a plus 2, a plus 2 plus 1, a plus 3, a plus 2 into a plus 3 equivalent to 4. A square plus 5a equivalent to minus 2. Check which case satisfies this. Check which case satisfies. Like that 4 cases we have to do. 1, 2, 3, 4. The case which satisfies, substitute the value, you will get the answer. I hope the idea is clear. Little bit of pen pushing is required. We have to take which case will satisfy. Maybe 1 case will satisfy, maybe 2 cases will satisfy. If you get 2 cases, there are 2 different numbers. Same idea we will use in this number. A natural number is there. 2 power a into 3 power b into 5 power c and so on. A plus 1 into b plus 1 into some p equivalent to x we will take. 2n has 2x factors. 2 power a plus 1 into 3 power b into 5 power c and so on. A plus 2 into b plus 1 into p equivalent to 2x factors. If it is 3n, 3n is 2 power a into 3 power b plus 1 into 5 power c and so on. A plus 1 into b plus 2 into p equivalent to 3x by 2. Where is, if I call it as 1, if I call it as 2, if I call it as 3. Simple 2 divided by 1. You will get an equation. You do 3 divided by 2. You will get an equation. Substitute this equation. Satisfies which one will give you the answer. Right? You will get a relationship between A and B. X will get cancelled. 2x by x is 2. P will get cancelled. You will get the relationship for A and B. Just substitute that relationship. Check whether you are getting the answer or not. Similarly, do 3 divided by 2. Model is clear. It is a round 3 problem. Very calculation intensive. Very calculation intensive problems. Calculation intensive models. Calculation intensive. I hope the idea is clear. Simply do 2 by 1, get the value of relation between A and B, substitute whether it is satisfying it. If it is not satisfying, then do 3 by 2. The values of A and B which will satisfy, put it out in 2ln, you will get the answer. Because of the space constant, I am not going to solve this question. I hope it is clear. We will do one more question, then we will wind up for the class. Please take one more question. Good question, we will try to take it. Question. Please take this question. Question is nothing but highest power of 2. N is nothing but 10 factorial plus 11 factorial plus 12 factorial and so on up to 1000 factorial. Highest power of 2. Now for me to determine this highest power of 2, what I will do is I will simplify this equation. N is 10 factorial. 11 factorial is 11 into 10 factorial. 12 factorial is 12 into 11 into 10 factorial. 13 factorial is 13 into 12 into 11 into 10 factorial. 14 factorial is, I will tell you why am I doing like this. 14 into 13 into 12 into 11 into 10 factorial. If 10 factorial, if I take common, these 1 plus 11 plus 12 into 11 plus 13 into 12 into 11 plus 14 into 13 into 12 into 11 and so on. 1 plus 11 is 12. 12 if I take common out. 12 into 10 factorial. It is 1 plus 11 plus 13 into 11. Here it will be 14 into 13 into 11 and so on. These are an even number. All are even. 1 plus 11 is 12 even. These odd. Even plus even is even. Even plus odd is odd. Odd number will not have any powers of 2. 12 into 10 factorial into odd. Till here it is clear. 12 it is nothing but 12. 2 6s are, 2 3s are, 2 1s are, 2 power 10. 10 it is nothing but, sorry, 12 factorial I am doing. 12 is nothing but 2 square into 3. 8 is 2 power 8 into k. 8 plus 2, answer is nothing but 10. 8 plus 2, answer is nothing but 10. A very good question when the factorial problems are added. Take 10 factorial common. 1 plus 11 plus 12 into 11 plus 13 into 12 into 11 plus 14 into 13 into 12 into 11 and so on. 1 plus 11 is 12. 12 if I take common. 12 into 10 factorial, 1 plus 11 is 12 even, 14 into any number even, 13 into 11 odd, 1 plus 11 12 even, 14 into any number even, 13 into 11 odd, even plus even plus odd is odd, 12 is 2 square into 3, 10 factorial is 2 power 8 into k, 2 plus 8 is 10. I hope it is clear. Close to, maybe in the work PPT only 50 questions are there. I am sure extra 30 questions I have taken which covers all the models. Just I am repeating one final all the concepts that we discussed. First one, second one, third one, all are different models. Co-prime factors, tens place, independently thinking, even number it is written, integral solution, odd numbers, HCF, remainder, Chinese remainder theorem, P power A concept, x, writing the number, it has n into x, morning we discussed, LCM, unordered pair, total minus none concept, 81 is nothing but write down it as GP, you will get the answer, product of two co-primes, 2 power P minus 1, P power A concept, LCM into HCF is n1 into n2 only when HCF is a factor of LCM, 15 is 5 into 3. Number of zeros concept, exactly 1 0 which is a 10k concept, successive division, when the quotient becomes the dividend in the next division, Chinese remainder theorem concept, set theory concept, when the remainders are not same concept, when the difference between the remainders is k times the difference in kth step. Next one, recurring decimal concept, divided by prime number concept, highest power concept, determining 2 power 96 by 97 is 1, 2 power 48 square will become plus 1 or minus 1, at least 1 is nothing but total minus none. Neither of the numbers should be a multiple, only one case, exactly one, this also we did. Successive division, identical cubes concept, denominator prime number concept, denominator composite number concept, nth factor from the right is number by nth factor from the left concept, how to find out the prime numbers concept, 800 direct negative remainder concept, what digital sum of a perfect square is always 1 4 7 or 9 concept, n factorial ends with x zeros, n is greater than 4x concept, right, multiplying and dividing by factorial, divisibility rule of 11 is take a group of 3 digits alternatively plus and minus, right? Thank you.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free, ANC.